The general trends we've talked about so far in this part, the between pressure and volume and number of moles and temperature, that is actually if the gas particles are behaving what we call ideally. So now the word ideal is like nothing is ever ideal, right? So we part of the assumptions of gas particles behaving ideally, there's two of them. One is that there's no intermolecular forces or connection between the particles. And as I've drawn them in that box, it looks like each gas particle is independent of the other gas particle. And that's kind of what we assume to be the case. The other thing is that the gas particles have a particular volume, but we're saying that the volume of the gas particles actually is what we say negligible compared to the volume of the container it's bumping around in. So as this turns out, for the first assumption that there's no intermolecular forces between the gas particles, that's pretty good if they have a lot of kinetic energy. So that's really good at high temperatures. And then the other one is that basically the size or the volume of the gas particle is negligible kind of compared to the container it's bumping around in. That's pretty good if there's a lot of space between gas particles. So that means if there's what we say a lot of low, or the pressure is pretty darn low. The density is low, the pressure is low. So in general, we say that if you have high temperatures, so that means the gas particles aren't bumping into each other, there's no interaction, and if you have relatively low gas pressures, meaning the volume of the gas particle itself is negligible relative to the container it's bumping around in, then the gas is behaving what we say ideally. So I mention that because we have, one of the very few equations we have for this semester in Intro to Gen Chem. PV is equal to nRT. And if you've taken physics before, well, that looks like a physics equation, okay? And where you just plug in kind of the variable for whatever the pressure is, whatever the volume is. N means what? That's moles, whatever the moles are, and whatever the temperature is. Now, so far, I have not told you what R is, but I'll go ahead and tell you that R is the ideal gas law constant. So it's just a constant. I'm going to give it to you. Bottom line is, do you see this variables? 1, pressure, 2, volume, 3, number of moles, and 4, temperature. 4 variables and 1 constant. So the last part I want to do this semester is the second part on gases, and we're going to do some number crunching with this, what we call ideal gas law equation.